electronic configuration of sodium ion Na positive, where it has 11. Okay, electronic configuration in general here, as we know, if we use the noble gases notation, we know that the noble gas notation, we have helium first by 2 electrons, the neon that takes what? 10 electrons. So this one takes 2 electrons and this one takes what? Takes 10 electrons. So if we want to find the sodium 11, its electronic configuration, we're going to use just neon, and when you use neon, that means we use 10 electrons of the 11 electrons here. How many electrons are left? 1 electron. Where this electron will be? Just need to memorize. Neon, when we use neon, that means the second period has been finished. The second period has been finished. That means what comes now on the third period is going to be 3s, and 3s will take 1 electron. So that means this one now is the electronic configuration of sodium 11 by using noble gases notation. But what about if we don't use noble gases notation? How the electrons will be organized for sodium? So always, if we remember, 1s will take 2 electrons, then it comes to 2s and it takes 2 electrons, then after 2x we take 2p, and 2p takes what? 6 electrons. Then here 3s, it will take what? 1 electron. So this is now by using SPDF electronic configuration, this is now the electronic configuration of what? Of sodium. And as you see, number of electrons here are 11, and we understand this order is going and after Aufbau principle. We know how to organize them: 1s, 2s, 2p. We can understand them from Aufbau, or we understand them from the order or the shape of the periodic table. Okay, now they are not talking about sodium 11, they are talking about the sodium ion, and the sodium ion here, positive is written up. When positive is written up, the charge is positive. That means now number of protons of sodium now are greater than number of protons are greater than number of electrons. So that means by how many? The positive, it means positive 1. That means protons are more than electrons by 1. That means what happens for sodium? Did it lose protons or gain protons? No. Losing or gaining are only for electrons, not protons. In all chemical reactions, losing and gaining and charges of ions, it depends on losing and gaining electrons. There is nothing called losing or gaining protons, because protons are inside the nucleus and they are not lost, they are not gained in chemical reactions. Good. So sodium now, when it is positive, that means number of protons are more than the electrons by 1. Why? Since it is the natural atom, it has to be 11 electrons, 11 protons. What becomes now positive 1? Why number of protons now becomes more than electrons by 1? Because that means 1 electron is lost. When 1 electron is lost, so it used to have 11 electrons. When 1 electron is lost, that means it's going to have 10 electrons. And now, when 1 electron is left or lost, it will be lost from where? From this one, the 3s1, or from the 2p, or from what? So look, when 1 electron is lost, usually and always it is lost from the higher energy level. It is lost from the higher energy level, and the higher energy level is represented by the number here, by the coefficient of the sublevel. So here the energy level number 1, here is energy level number 2, here is energy level number 2, and here is energy level number 3. So which one is the highest energy level? It's 3. So that means the electrons will be lost from here. So when the electron is lost from here, it has only 1 electron. When it's going to be lost, what will happen then? So this one now is only the electronic configuration that will be left. So that means it's 1s2, 2s2, 2p6. Here in the traces now, they didn't rate you what is the first, they rate you what is on the last. So what is the last part of this electronic configuration? You're going to see that it is what? 2p6. So you got to choose here 2p6 as the answer.